Nobody would ever call it ethyne. Hey there, OChemNinjas. Welcome to 15 minutes of basic nomenclature examples. We'll start simple and move our way up the ninja level ladder. This isn't a video about the rules of nomenclature. I have a separate video going through all the rules of nomenclature that I'll link to down below. In short, every name is made up of 5 parts. There may not always be stereochemistry, and sometimes there'll be substituents on the molecule, but every name needs a syllable based on the parent, the unsaturation, and the priority functional group. This video will only focus on those last 3 syllables. This video is really only going to focus on the parent and unsaturation syllables. If you'd like other examples using stereochemistry, substituents, or priority functional groups, I have links to those videos in my nomenclature playlist in the description. I have a very systematic, organized way of going through IUPAC nomenclature to make sure you don't miss anything. So let's start even with a fairly simple example. CH4, 1 carbon, 4 hydrogens. We need to know the parent name for a 1-carbon hydrocarbon. For a 1-carbon hydrocarbon, the parent syllable is meth. This molecule does not have any double or triple bonds. It has no unsaturation, so we use AN to indicate that there's no unsaturation. And there's no priority functional group, so we put an E on the end. Methane is the parent name for this hydrocarbon. This molecule has no substituents and no unsaturation and no stereochemistry, so this is just the name for this molecule. The name for this molecule is methane. Let's keep going and see what happens when there's more than 1 carbon. This next example has 2 carbons in the longest consecutive chain, so we need to know the parent name for the 2-carbon hydrocarbon. With 2 carbons, the syllable that describes 2 carbons is F. Again, there's no unsaturation and there's no priority functional group, so we'll use ANE to finish out the molecule. This parent hydrocarbon is ethane. This molecule also has no stereocenters, no substituents, no priority functional group, so ethane is just the name of this molecule. This 2-carbon hydrocarbon is ethane. With 2 carbons, there's room to add unsaturation. So let's work through this example. This molecule has 2 carbons in its longest consecutive chain, so the parent hydrocarbon for 2 carbons is ethane. But this isn't going to be ethane. AN is the syllable for unsaturation when there is no unsaturation. And this molecule does have unsaturation, it has a double bond, so it's not going to be ethane, it's going to be ethene. This molecule has no stereochemistry or substituents or priority functional groups, so the technical name for this molecule is ethene. But I gotta tell you, nobody calls it ethene, everybody calls it ethylene. This is one of the common names from antiquity that has stuck around so long that we use it interchangeably for the technical name. If you see this molecule, you're going to call it ethylene. Let's look at the case with a triple bond. We still start with the number of carbons in the parent hydrocarbon. There are 2 carbons in the longest consecutive chain. The parent hydrocarbon for 2 carbons is ethane. But again, this isn't going to be ethane, is it? It has the triple bond in it. AN signifies a single bond. This has a triple bond, so it's not going to be ethane, it's going to be ethyne. Like with other ones with no stereochemistry, substituents, or priority functional groups, that is going to be the technical name for this molecule. The technical name for this molecule is ethyne. Although this is another one where nobody would ever call it ethyne. The common name for this one is acetylene. There's really no circumstance where you would ever call this molecule ethyne. You would just call it acetylene. For this one, go ahead and pause the video, see if you can come up with the name for this molecule. Start with the number of consecutive carbons in the parent. For this molecule, that would be 3. The common name for a 3-carbon hydrocarbon is propane. And with no unsaturation or stereochemistry or anything else, that is the name of this molecule. This molecule is propane. It may seem silly to go through this whole analysis for a fairly simple molecule, but if we can get the steps in order, if we can be very systematic about it, the complicated molecules will be much simpler. Go ahead and pause the video, see if you can come up with the name for this molecule. As always, we'll start with the number of carbons in the parent hydrocarbon. For this molecule, that would be 3. Our 3-carbon parent is propane, but this molecule isn't going to be propane. It has the double bond, so it's going to be propene. Now that our hydrocarbon is getting longer, we need to see if it matters where the double bond is placed, and if so, we need to update the name to indicate its location. For this molecule, we could think there might be 2 different places we could put the double bond. We could put the double bond here, or we could put the double bond on the right side of the molecule. So it looks like it does, yes, matter where the double bond is placed. But if we look at this other molecule and we number it from right to left, we can see that these are really the same molecule, they're just pancake flips of each other. So these are not 2 different molecules. This is one molecule drawn twice. So for a molecule like this, where no matter where we put the double bond, it will always start at carbon number 1, we do not need to update the name indicating where the double bond is. So the name for this molecule will be propene, though this one also goes by its common name of propylene. Pause the video, see what you do with this next example. As always, we'll start with the number of carbons in the longest chain. That longest chain is 3 carbons. Our name for our 3-carbon parent is propane, but this isn't going to be propane. It has the alkyne, so we'll update the name to be propyne. Doesn't matter where the triple bond goes. If we look at numbering this molecule, we might be inclined to number it 1, 2, 3 from left to right, but that would not follow IUPAC rules. IUPAC rule says the unsaturation should go at the lowest possible carbon number. We should instead number this molecule right to left to give the alkyne the lowest possible number. And with that, we see that just like the previous example, whether we drew it right to left or left to right, the alkyne will always be at carbon number 1, so there is no difference where we put the alkyne in this molecule. Because it doesn't matter where we put the alkyne, the name of this molecule will just be propyne. And as far as I'm aware, there's no common name for this molecule. Go ahead, pause the video, see if you can come up with the IUPAC name for this molecule. As always, we'll start with the number of carbons in the longest consecutive chain. This example is meant to show you that we don't have to draw the chain in the regular zigzag horizontal line that we typically do. Parent hydrocarbons can be rotated to any conformation. It doesn't change the name just because the molecule is orienting in a different conformation. So even though we're going from top to bottom, there are still 4 carbons in this molecule. The 4-carbon hydrocarbon is butane. And without any unsaturation or any other parts of this molecule really is butane. Pause the video, see if you can come up with the IUPAC name for this molecule. For this molecule, there are 4 carbons in the longest consecutive chain. Our 4-carbon hydrocarbon is butane. This molecule is not going to be butane though. It has the double bond, so it'll be butene. Doesn't matter where we put the double bond. We could imagine 2 other versions of this molecule where the double bond is between other carbons. While these 2 are identical versions of each other, they're just pancake flips. This is the same molecule drawn twice. This molecule is different from the original molecule. So yes, it very much does matter where the double bond is in this molecule. So for this molecule, we need to specify that at the 2 position, we have the alkene. So it would not be good enough just to say butene. For this molecule, we would need to say but2ene to signify that the alkene is at the 2 position. By the way, this isn't an official example, but this molecule is but1ene. You might see some places where the 2 is popped out front as 2-butene or 1-butene. That is an old method of IUPAC nomenclature. It's not the official method anymore. The official method has the number immediately preceding the syllable it is identifying. The 2 isn't telling us where the but is, it's telling us where the ene is, so the 2 should be immediately preceding the syllable ene, indicating the alkene is at position 2. This, though, isn't actually the official name yet. There's another way we could orient that double bond. The double bond in this example is in the E orientation. This is in a video about how to figure out if a double bond is E or Z. I have a link to that video I'll link to in the description below. But since this is an E alkene, we need to put 2E in front of the molecule to indicate the stereochemistry of the alkene. Again, this isn't part of the video, but but1ene does not have E or Z geometry, so we would not need to put any stereochemistry in front of this molecule. This would be the other orientation of but2ene, and this one would be the 2Z but2ene. Pause the video, see if you can find the name for this molecule. As always, we'll start with the number of carbons in the longest consecutive chain. That's 4. Our 4-carbon hydrocarbon is butane. With a triple bond, this isn't going to be butane, it's going to be butyne. Just like before, it is going to matter where the triple bond is. Can you draw the other versions of butyne and name those as well? There's only one other version of butyne, and it would have the triple bond between carbons 1 and 2. Like before, if we tried to put the triple bond between 3 and 4, that would just be the pancake flip of the same molecule. That would not be a unique molecule, so this is the only other version of butyne. That means it does matter where the alkyne goes, and so we do need to indicate its position. At the 2 position, we have the alkyne. Putting these together, writing out the name of the molecule, this would be but2ine. And the other version would be but1ine. There is no E or Z geometry about an alkyne, so the name of this molecule really is but2ine. Here's the next example. Can you find its IUPAC name? This molecule has 6 carbons in its longest consecutive chain. Again, it doesn't matter that they're not in the horizontal zigzag backbone. The 6-carbon hydrocarbon is hexane. And without any other decoration, that is the name of this molecule. This molecule is hexane. Pause the video, see if you can find the name for this molecule. This molecule has 7 carbons in its longest chain. It doesn't matter that they're not horizontal. The 7-carbon hydrocarbon is heptane. This molecule doesn't have any unsaturation or any substituents or stereochemistry or priority functional groups, so the name of this molecule is heptane. What happens when there's an alkene and an alkyne in the same molecule? Pause the video, see if you can work through the name for this molecule. Really, nothing changes. We just need to be careful how we package everything up in the final name. There are 5 carbons in the longest consecutive chain for this molecule. Our parent carbon with 5 carbons is pentane, but it's not going to be pentane. It has unsaturation. It has an alkene, so we can update the name to pentene, and it has a pentyne, so we can update the name to include both the ene and the ine. The way we do that is alphabetical order. So this would be pent, ene, ine. Notice we save our priority functional group syllable to the very end. In this case, it's just the E because there is no priority functional group. There is no E between the ene and the ine because that E is what represents the priority functional group. It does matter where the unsaturation is in this molecule, so we need to indicate its positions. At the 1 position, we have the alkyne, and at the 3 position, we have the alkene. So when we put it all together, we would have pent, 3, ene, 1, ine. We do need to indicate the geometry around the alkene. This is an E alkene, so we would say 3E, pent, 3ene, 1ine. For basic molecules with only unsaturation, it gets pretty repetitive. So let's really go for it with a high Ninja level 1 for our last example. Pause the video, see if you can find the name for this molecule. Even though it looks more complicated, the rules are exactly the same. There are 9 carbons in the longest consecutive chain. The 9-carbon hydrocarbon is no name, but it's not going to be no name. There are double bonds in the molecule, so we'll update the unsaturation syllable and make this molecule nonene. It very much matters where those double bonds go, and how we number the molecule is also going to matter. Remember, our IUPAC rules say that the alkene should get the lowest possible number. However, this is a case where no matter which side we start from, the alkene is at carbon number 2. When the first group ties, we move into the next group. The second alkene starting from the bottom starts at carbon number 4, but if we had numbered from the other direction, it would start at carbon number 5. So we number in this direction in order to give all of the alkenes the lowest possible set of numbers. That means at carbon number 2, we have an alkene. At carbon number 4, we have an alkene. And at carbon number 7, we have an alkene. How do we handle this when there's more than one alkene? We use the syllable tri to indicate that there are 3 alkenes. 2 would have been di. So this molecule will be nona 2,4,7 triene. We separate the letters from numbers with hyphens, and we separate numbers from numbers with commas. The one letter you may not have been expecting is this A. When putting this molecule together, if the numbers weren't here, we would have an N next to a T, and phonetically you can't really say an N sound next to a T sound. Non triene wouldn't make any sense. So we add the A as a buffer syllable in order to allow the molecule to roll off the tongue a little bit more easier. Nona triene. We use the numbers to indicate where the alkenes are, and we get nona 2,4,7 triene. We do need to indicate the E and Z geometry of these alkenes. The way we would indicate that in front of the molecule is we would say 2Z, and even though the other 2 alkenes are E, we do not combine them together. We would say 4E and separately 7E. The full IUPAC name of this molecule is 2Z, 4E, 7E, nona 2,4,7 triene. Molecules with only alkanes, alkenes, and alkynes may be fairly straightforward in their analysis, but if we can be rigorous about this part, it'll make the more complicated molecules much easier to accomplish.
Thanks for training with us today, ninjas. Check out this other content to see if you can level up even further. As always, don't forget to like and subscribe.